So our next speaker is Emily Shalgo from PNC. Emily recently graduated from Carnegie Mellon University with a master's degree in public policy and management with a concentration in cybersecurity management. Emily's interests lie in penetration testing, threat analysis, and applying the study of human behavior to the field of cybersecurity. Please welcome Emily Shalgo.
Thank you all so much. Thank you for having me here. Quick disclaimer to start off with, this is related to work that I did with my master's thesis, and it's not related or affiliated with my current employer in any way. So as he said, my name is Emily Shalgo. I recently graduated from Carnegie Mellon University with my master's degree in cybersecurity policy and public policy. And before that, I actually got my undergrad in political science and psychology. So I had a little bit of a deviation to get into the world of cybersecurity. But I've always kind of had a fascination with the whole concept of human behavior and how behavior and decisions drive all sorts of things in life. And I actually came very close to pursuing a PhD in cognitive science until I realized that I already hated it and didn't want to do that forever. So, but that's an interest that has persisted with me throughout my life and really kind of informed this research that I did. Okay. So just a few things that I'm going to go through here. I'm going to go through the background that kind of led up to me deciding to do this research, the framework that I created through my program, kind of the future directions that I hope this work can possibly take, and just a little bit of wrap up, and hopefully time for some questions. So the study of human behavior in cybersecurity is something that's gaining traction. So that human factor in security that kind of helps us work through the profession. Unfortunately, the focus is still greatly on the human as the vulnerability. So the computer grandma is a great example, that the user is the person that's going to be causing the problems for us. But the adversary is still kind of the hacker in the hoodie, that person that we can't see, they have no face. And that's where these things like the attack framework start to consider the behavioral aspects of security, and that really is a kind of new area that's gaining some traction. Another thing that is researched a little bit recently is kind of the concepts of game theory and behavioral economics. And those studies are very interesting, but they're very math heavy. And I read a few of them, and they were just a whole bunch of numbers and symbols, and they were kind of crazy. They weren't something that you could hand to a manager and say, hey, this is something we should implement. So that was kind of something that I saw as an area that could use some more research, and that was what I decided to pursue for this thesis. So I had sort of a few ideas in mind when I went into this. I had some very lofty ideas. The first thing I talked to my advisor about is, what if I could get aggregated pen test data from some organizations and kind of look at those pen testers as adversary emulators? What did they do? What kind of are those things going through their minds? Maybe even interview them. That was a very grand idea. Turns out no organization was going to let me have access to that data. So that was not something I was able to pursue. However, my advisor is very big on attack, and he steered me towards that, and he said, look at this as something that you can work with. You can take an APT or a few APTs and model them using this framework and kind of get that sort of same result without having to go through organization-specific data. So that was what I did. And I feel kind of left out here because I feel like I'm the only person who did not start with a spreadsheet. My method is post-it notes on the wall. That's what I got. So the first thing I did, and the first thing that an organization could do if trying to do the same thing that I did, is identify what those top threats would be. So I worked with using data from APTs because that's very easily accessible. Shout out to that wonderful attack website that splits it up by APT and maps it to the tactics. That was super helpful for me, as well as a few other organizations as well. So what a company could do is look at, what are my top threats? Maybe that goes by sector. In the financial sector or government, something like that. Maybe the size of my organization, is it large or small? Or even my geographic area as something that would help me identify those threats. And there are reports published, of course, every year by various organizations about that. So then I looked into the attack methods of those threat actors. And that was probably the most time-consuming part for me. So someone keeps asking about the time that projects take. So this took me probably a couple of months to really deep dive into this information and kind of synthesize it together. So then what I ended up doing was realizing that this had a very good logical progression of decisions to it, to the point that I could almost look at it and say, I can imagine what it's like to be the human being staring at the target, figuring out how to move through. So what I ended up doing was I formulated this in the form of a decision tree. Basically taking what is that threat actor's primary method of attack, what would be their ideal, what would they want to do first. Usually that's spear phishing because it's kind of the easy way in. But what if that doesn't work? Do they just give up? Probably not. There's usually something else that they do next that's kind of a backup to try. And that was kind of what I was thinking when I went in, is this is not like a linear progression. This is something that keeps going. So then the last thing an organization could do once they made this tree, which I'll show you a few of them in a minute, is synthesize that with their own organizational weaknesses. So people have talked earlier about taking the attack tactics and techniques and kind of overlaying that and saying, what's our weaknesses? Where are we, red, yellow, or green on each one? So now instead of just laying out that on a chart, we can lay that out as opposed to what our biggest threat actors are going to be doing. And I'll show you that here in a moment. And also, if you're playing bingo, this is the place for you. So I hope you can read all of that. But so the first organization that I used for this was the Turlo Group, because this was one of the most simple ones that I found, because they don't use too many different tactics, but they're fairly well known, fairly well documented. So as I pointed out, usually start with spear phishing. If that's a success, then they'll move on to the next stage of process discovery. And then they'll move on from there, if that works, to malware execution, data exfiltration. Boom. That's their ideal attack if there's nothing in the way. However, if they fail somewhere along that path, it's not over. There's something else they can try. They can try brute force. They can try lateral movement. There's other things that can happen. So if you look, the check boxes with the green are a successful attack, and the red X's are where you might reach a failed attack with no other ideas. So for an organization to have this would be very helpful to say, okay, where are those critical nodes of red versus green? Where can I cut those off? But that doesn't mean I have to cut them off right at that red and green point. Where can I roll that back? Can I keep it from ever getting that far? And even more importantly, where are those other reds earlier on where we can stop that attack before it even gets that far? I'm going to show you another one here. This is for APT10. You're not going to be able to read it. You're not meant to. It's a crazy one. So this was actually even the sort of oversimplified version of what APT10 does. This is assuming they start with spear phishing, which they don't always, but it's just sort of an idea of how complex this can get if you really start to lay out everything that a more complex APT can do. So as you can see, there's a bunch of different branches. There's a bunch of those different red and green nodes, but there's also a whole lot more places that that attack can fail. So that can be really important for an organization to roll that back and say, okay, how can we cut that off in the most places, the most efficiently? So now if I'm an organization that has already done that risk assessment and vulnerability assessment and knows where on the attack framework we are strongest and weakest, now instead of just staring at a grid, I can overlay that with this and say, is there a branch where we're good? Is there a branch where we're not good? Are there a lot of branches where we aren't good? And how can I prioritize those mitigations? So some future directions that I hope this can go eventually is to kind of get more of a live data format with this, that an organization can actually implement maybe some of their previous history or their own pen test and kind of get an idea of what other vulnerabilities and risks are out there that aren't just limited to the APT kind of threat. I'd also love to see someone with more of a math or statistics background get a hold of that, because there were studies that I read with the behavioral economics were very mathy, but they were very informative in terms of like what is the probability of something happening. That's not something that I felt qualified to try to take on, but it was very interesting to me. So just to wrap up, this framework can be used for the prioritization of mitigations within a company, and it can also allow a company to personalize their policies and their priorities. So what is our biggest threat in our sector, our geographic area, and how can we work that in with the vulnerabilities that we have? And like I said, it's not just for APTs, it can be applied to other threat actors as well. But since that is kind of the main focus of attack at this point, I kind of just worked it there. And that's all I have at this point, so I'll take questions, and there's my Twitter, it's just my name, please follow me. That's all I got, thank you.
So, questions for Emily? We have a few minutes. We can take it in the back corner.
Of course it is.
So let's just say, go CMU, go Tartans.
Woo!
So it's intriguing, and particularly I have maybe two questions. The first is, you mentioned using this for organizations to improve security and know their gaps. Have you thought about using this to identify actor groups, particularly where I'm taking it to organizations and agencies that look at all the actors and look at activity and try to identify what group is this?
So I think that's a little bit of a chicken and egg situation because I used that information about the organization to make that. So I guess I could see how it could be used for that, but I think it'd be a little bit circular to try to implement.
Maybe not necessarily the data set that you use, but just the whole idea of the way you map things and pursuing it. Because I'm thinking about things such as timing. You know, the time between different elements may be unique. A certain group may do something immediately, another group may wait a week or a month in order to the next activity. So adding into that would be interesting to try to categorize different threat groups.
Absolutely. For simplicity's sake and demonstration's sake, I didn't try to incorporate anything like timing or anything like that, but that's certainly a consideration.
Thank you.
Other question all the way over there?
Yeah, I gotta
Hardest working man.
I gotta work on my own.
Let's go for it.
My question was for your trees, did they ever reconverge where you had an attacker do maybe 2 or 3 different ways to achieve, say, lateral movement, but then they went back to their same technique for the next stage of their attack?
Yeah, so actually here, I'll go back to that. A lot of them have sort of similar, like the later half of the branches. So for example, this one always ends with the malware execution, data exfiltration, because that's pretty much their sole tactic at that stage. I couldn't visually make it converge, but that's effectively what it does.
Other questions? Going once, going twice? All right, well, please join me in thanking Emily.